On our last video, we created a function that deleted or popped the head node or deleted the first node on our linked list. For this video, I'd like to create a function that will delete the tail node or the last node of our linked list. So let's get started. The first thing I want to do is create a function prototype. I am going to call that pop tail, but the data type will be a node, and it's going to take one parameter, and we're going to use call by address. So we're going to put a double pointer head, and this head will take on the address of this head. So now I'm going to copy this function prototype and put it at the bottom and create a definition for it. Before I start coding, let's go to the right hand side where I have a pictorial representation of our current linked list. And our current linked list goes in the increment of 10. So we have 5 nodes. The first data is 10, second data is 20, third data is 30, fourth data is 40, and the fifth data is 50. If I compile it, you'll see the representation of this pictorial. So let's talk about the logic. I'm going to create a activation record for pop tail. Our pop tail will have a head node that will take in the address of this head node and will point to this head node. And so what I want to do is I want to create 2 extra pointers. I want to create a temp pointer, and the temp pointer is the pointer that we want pointing to the node that we are going to delete, and in this case the last node. And I also want a current pointer. And all 3 of these pointers will be pointing to our head node. So let's go ahead and code that. But make sure that you have a star or an asterisk in front of your head, because here we have a double pointer, and a double pointer is a pointer to a single pointer. So we want this to be a single pointer. And let me go ahead and create a current node. I also want to create a variable that will count each node as we traverse through them. So that way when we do delete a node, I want to be able to print that node out and be able to get a printout of which index we deleted. We're just going to call this I, and we're going to set that equal to 0 because our first index starts at 0. And so our first condition is always going to be if our head equals null or if our list is empty. We always want to have that on there just in case we do not have a list. How do we know if our list is empty? Well, if our head is pointing to null, then we know we have an empty list. If, and don't forget to put the asterisk head equals null, then all we want to do is printf the list is empty. And then we simply want to exit the function with an exit 0. Let's test to see if this condition is true. I went ahead and commented out all of the function calls so that we should have an empty list. And again, when you type in pop tail, make sure that you put an address, the ampersand in front of the head. All right, let's run it. The list is empty. For our next condition, what if there is only one node on the list? How do we know if there is only one node on the list? Let me draw the logic on the right hand side, and I'll draw it at the bottom of this white space. Here we have our node, and let's just say it has a data of 40. And then we have our next link, and then I'm just going to abbreviate the head, current, and tail. So we have a head pointer that's pointing to that node. We have a current pointer that is pointing to that node. And we have a temp pointer that is also pointing to that node. Well, we know that we only have one node if this next link is pointing to null. In other words, if temp arrow next is null, then we have one node. And if that's the case, if temp arrow next is null, then we want to free temp and then set all of these 3 pointers to null. All right, so let's code that. Else if temp arrow next is null, then we want to free temp. But we also want to set all 3 of our pointers to null. Let's go ahead and test this condition, and let me uncomment the first. The list is empty. So let me add a print statement that will let us know that we've deleted a node, and this is where our I comes in. I am going to put the print statement on line 67, and it's actually the same print statement that we use for our popped head function. So I just copied that, and I'm going to put it right here. What this will do is it will print our node index in this format specifier matches this variable, and the data that was deleted. So let's run this. There it is, index 0, because we only have one node and data 40 was deleted. So now our list becomes empty and we have no nodes. For our final condition, what if the list contains more than one node? And this is actually the pictorial representation that I currently have here in this white space. And so we have 5 nodes. So I went ahead and uncommented these function calls so that we'll have all 5 of our nodes printing. 10, 20, 30, 40, 50. Now you may ask yourself, why wasn't 50 popped because I still have this? Well, the main reason is because we haven't addressed that condition yet. We've addressed the condition of the list being empty and the list only containing one node. But this is false and this is false, so this doesn't do anything right now. And that's the next condition that we want to target, is if there is more than one node. But before I do that, I want to draw on the right hand side the logic. When deleting the last node of our list or popping a tail node, what we want to do is we want to traverse both temp and current. And when we do that, we want to have temp to be pointing at our last node and current to be pointing at the node before the last node. Actually, let me switch these two for drawing purposes, and I'm going to make this current and I'm going to make this temp. So this is how we're going to do it. So we're going to traverse temp. And how do we know when to traverse temp? If temp's next value is not null, then we know that there are more than one node on our list. If the temp's value is not null, what we want to do is we want current to follow it. We're going to assign temp to current. So we're going to set current to assign a temp. And I'll explain this as we go. It's kind of weird right now. And then we're going to traverse temp to the next node. And after we traverse temp to the next node, we are now in index 1. And so we want to increment I to I++. And so now we're going to look at the temp's next node. Is it null? No, it's not. So we want to assign temp to current. So current will be following. So in this case, order matters. And then after we assign temp to current, current will move to the next node, and then we're going to traverse temp to our next node. And then we're going to increment I. So now I is 2. After we increment I, we check our condition. Does temp's next value equal null? Well, if it doesn't, the first thing that we want to do is we want to move current. And then we want to traverse temp to our next node. And we want to increment I. So I is now 3. And then we check our condition again. Does temp's next value equal null? Well, it doesn't. And if it doesn't, then we want to assign temp's address to current. And so current will now equal, or will now point to the next node. And then we traverse temp to the last node. We then want to increment I, so I is now at 4. Then we start our condition again. Does temp's next value equal null? Well, it does. And if it does equal null, then we're going to exit out of our traverse loop and we're going to free temp. And then we're going to set both current's next and temp to null. Okay, so let's code that. Since we've already used else if, since this is our last condition, we just want to use else. And being that we are traversing while temp's next, because that's what we want to examine, does not equal null. And if that's the case, if it doesn't equal null, we want current to follow. So we're going to assign temp's address to current. Okay, and then we're going to move temp to the next node, and then we're going to increment I. Once this condition becomes false, we're going to exit out of this while loop, and all we want to do is free temp, and now we want to set current's next link to null, and then we want to set our temp pointer to null since we freed that. Okay, so now let's test this condition. 50 should be popped. So let me run it. If you notice, 50 is pop. Let me add this print condition, and you have to put it before free temp because this will tell us what this is currently pointing at. It'll print it and then it'll free it. And so now let's run this. There it is, index 4 with a data of 50 was deleted. And so now we only have 4 nodes left. So 10, 20, 30, 40, and number of nodes. Now, as with our other functions, we can also do it another way. Instead of call by address, we can return the address. And so let's do that. And it only takes very little modification. So let me copy this, and we're going to call it poptail1. So we know that all of our ones are returned by address or return the address. And then this has to be a pointer. So no data type, but a pointer, because a pointer holds an address. So when we return the address, this is going to be an address. And then we're going to make this a single pointer. And then I'm going to copy our poptail function, and I'll just put it right above it. And we're going to modify it a little bit. So this is going to be a pointer. We're going to call it 1. We're going to take away the double pointer. Now, because we did that, anywhere you see an asterisk in front of head, you're just going to remove that asterisk. And then at the end, we're going to return the address of that head. So let me draw this on the right hand side. So what's happening is this is currently pointing to this node, the head in our main function. This head will have its own address. So let's just say that this head has an address of 0x50. When we call this function up here, we would have to call it differently. So we're going to say poptail, or we're going to have to return it. So it's going to be head. We're going to have to assign the address of it to head, poptail1, and then we just want the address to be returned. Let me draw it here. So when we call it head, and this is in main, this is actually the same thing as head, and we're assigning it the address of 0x50. So now this becomes 0x50. This head basically becomes this head. And so let's run this. And there it is. It should delete 50. Now you can run them simultaneously. So let me delete this, and then the call by address and the return by address. So 2 nodes should be deleted. There it is. So index 4 was deleted and index 3 was deleted. So that in a nutshell is both our poptail return to address function and the poptail call by address function. Thank you for watching.